Did you think I was going to say welcome back? I was about to, but then I reviewed all my videos and I see that every time. So, hey there, welcome. In this lesson, we are going to expand upon what we did in our previous module and just keep doing the CTEs and subqueries that we learned. So looking at our outline, this is going to be broken up into two parts. Similar to our previous module, part one will go into how multiple CTEs work. We are introducing a new function, and that's going to take a little bit of time, about 23 minutes. And then for part two, we'll just replicate this by breaking down our CTE and doing it as a subquery. So that will take 12 minutes. And then in the following module, we will have some practice examples that you can do on your own. So with that, let's get started. In our last module, we learned how to do subqueries and CTEs. Your next question might be, what if I want to do multiple of these CTEs? I'm not able to do my analysis in one step. I need more than one. Well, luckily BigQuery and the SQL language can support that. So we're going to walk through an example showing how to go through multiple CTEs. We'll break down a new function that we're going to learn, and then we're going to open up the BigQuery console and review that. So here we are with our first CTE, and we start it just like normal with our CTE name. We're going to call it base as, and it's this chunk right here. And if you're looking at it, you might see, oh, there's something called geopoint. This is weird. I don't know what that is. Don't worry. We're going to go over that in a second. To do our second CTE, what we do is we just have another comma. We name our CTE something new. We're calling this dist as, and then when we look at where are we pulling our data from, we're pulling it from base. So what's happening is first we do this query called base that gets saved into the short-term memory of SQL. And then when we make this query right here, we are calling base. We're calling, hey, that query I did, now I want you to do some stuff on top of it. And then to end the multiple CTEs, you just do it like normal. You have your final query, and that can be from our distance table. So if we look at the chain, we see yellow, he starts here, then we use that as the from, we make our new CTE, he's green, and then for our final query, we query him at the bottom. So the order of operations. Base is the first query, distance uses base as a quote table, and then our final query uses the dist CTE. So let's break down this geopoint and this st distance because those are new functions. So the first one we're going to go over is this st geopoint. And how this function works is it has the function and then it takes an input of a longitude coordinate and a latitude coordinate. So this converts a longitude and latitude coordinate into a point. And if you're like me, you need something visual. So if we were to graph this, we have longitude. Longitude is long. And then we have latitude. Latitude's going to be our x-axis. Suppose we have these 2 points. We're starting with a latitude of 12, longitude of 5, and we're ending with a latitude of 14 and a longitude of 9. So let's plot that. This here would be our start point, 12 for longitude, 5 for latitude. And this would be our end point, a 14 for latitude and a 9 for longitude. So what this st geopoint does is it takes this 12 and this 5 and it converts it from just random numbers into a point. So now when Google BigQuery sees this, it knows, oh, I'm not just dealing with numbers, I'm dealing with distance, and we're going to do something cool with that. So that's what the st geopoint does, is it converts a latitude and a longitude into like a distance spatial point for BigQuery. St distance takes in 2 geopoints from Google BigQuery. So we need the end and we need the start, and then it calculates the distance from it. So you see this st geopoint, that is going to be the input for our st distance. So st distance, he takes in 2 GPS coordinates and he calculates the distance between them. And so we can see here the difference between st geopoint versus st distance. Geopoint are the circles, And distance is the length between the circles. Our output is going to be in meters, and that I found in the Google BigQuery documentation. The input, like we said, requires geo points. So if you have a latitude, longitude, step 1, convert it into a geopoint. Step 2, then you can calculate the distance. And the last thing to note is that the distance is, quote, as the crow flies. And that's kind of like an English idiom, and what that means is we're just going to find the straight line between A and B. We're talking about our taxi cabs and New York City bike trips. And I would say probably 100% of the time when you go from point A to point B, you don't go in a straight line. And that's because you have traffic, there's buildings, there's obstacles in the way. So your actual real distance is probably very long compared to as the crow flies. But when it comes to analysis, a lot of times we're not able to track the exact movements that someone took to get from A to B. And so this is a good placeholder for that. Okay, now that we spent all that time looking at that, we are going to open up the example that we reviewed in slide 2 in the BigQuery console. Okay, so I'm looking at this, I'm like, this looks like insanity, but it's just because I had to write everything down. But we have effectively 3 parts for this example. Part 1, we're going to create a query that pulls in our bike ID, our month and trip, our start station, lat long, trip duration. Then we're going to convert our lat long into a geopoint. We're going to convert our trip duration from seconds into hours. And then we're going to scrub any data that has a lat long value of 0 and any data that has a missing trip duration. So let's start with part 1, and then we'll look at part 2 and part 3. But this is going to be CTE 2, and then this will be the final query. Okay, so for this, because my instructions are so long, I'm going to do split screen today. So I added my new query editor, I click the drop down, and I'm going to say split to the right. And then I'm going to just copy this first chunk, and I'm going to put it right here. Okay. Okay, so and I say taxi cab, but that was just me not thinking clear. We're using our bike data. Okay, so part 1, create a query that pulls in these columns. So this is going to be our select. We want bike ID, month, start, end, and trip duration. Okay, so I can do select, and I have an unclosed comment, they're saying. That's because there we go. Okay. So I can't remember anything. So let's see, ID. Let's look at ID. Okay, bike ID. Select bike ID. For the month, we're going to do extract month from, we need something with a date. Start time, looks great. From start time as month. We want the start station longitude, latitude, and the end station longitude, latitude. Okay. So let's just look up lawn. Okay. And we see that it's spelled exactly like we would expect. So I'm going to put in a comment here. Getting coordinates for start location. And we have start station longitude, and then start station latitude. Then we have end, let's put another comment, getting coordinates for end location. And we have end station longitude and end station latitude. Now, you're going to notice as we go on with these really long query tasks, it's very, very important that we stay organized. So that's why I'm grouping my start station together and my end station together. You could organize it by the longitudes together and the latitudes together. That's fine. What you don't want to do is do start station longitude, then end station latitude or something like that. Okay. So now we've done 1, 2, 3, 4, and then we want trip duration, okay? And then I don't remember what trip duration's called. Oh, it's just called trip duration. Oh, wow, okay. Well, that was easy. So now we have trip duration. All right, so now we've done part 1. Part 2, convert the start station and end station lat long into a geopoint using the function stGeopoint, longitude, latitude. Okay, so I'm going to put this right underneath here. So I'm going to do stGeopoint, open parentheses, and it's G point I'm seeing. So just be careful with that. I thought it would just be geo point, but I guess they have a G in it. Maybe it's for like Google or something. Okay, stGeopoint, and we do the longitude and then the latitude. So this is going to be our start one. So we're going to do start station longitude, comma, start station latitude as, and we're going to call this start geo. Okay, now we're going to do the same thing for the end location. stGeopoint, end station longitude, end station latitude as end geo. And I forgot my extra G in here. Okay, so now we've done part 2. Part 3, convert trip duration from seconds into hours. Okay, that's easy. We can just put right underneath trip duration, we can do safe divide trip duration, comma, 60. So we're going from seconds into hours as trip hours. Okay, now that we've done all of our selects, now we're ready for our from where? From our table. Our bike trip table. Okay, now it's time to scrub or filter our data. Where now we need any of these geopoints can't have a 0 in it. And why is that? If you're a 0 in the latitude longitude space, I believe you're in like the middle of the ocean. So we know that that's bad data. Okay, so where start station longitude is not equal to 0, because longitude and latitude, they are very often negative and positive, but when it equals 0, that's when you know it's like, okay, not good. And start station latitude, not equal to 0. And then we'll do this for the end station. And then what's the last one? And scrub any data that's missing a trip duration. And we're doing that just for good measure, because if we don't have a trip duration, we're going to assume that it's just bad data. So trip duration is not null. What does this mean? This means that we have a value. And I spelled it wrong. Okay, trip duration is not null. And I'm getting an error because I had a little typo here. Gorgina. Okay, so I added in a new filter because when I first pulled this back, I pulled back a lot of data. And I don't want you to do that. So we're going to only keep data for the year 2014. So we're going to add that here. So we have and the trip duration is not null, and extract year from our start. What is it called? Start time? Start time equals 2014. Okay. Okay, so we still have a lot of data, which is good. Okay, we see that we have our bike ID, our month, our start station long, lat, and then we see with our start geo, it has this thing called point next to it. And what does that mean? This is something specific for BigQuery, and this is letting you know, hey, these aren't numbers anymore. This isn't just some random decimals like the end station, longitude, and latitude. This has a specific type of format, kind of like with our date time, right? You could have a date time and it's just like a bunch of crazy numbers strung together. But if you say that this is a date, now it has a special meaning and you could do special functions to it, and we know how to handle it. So we can see with our NGO, it has this thing called point to it. Okay, great. And then we have our trip duration and our trip hours. So everything looks really good. We are on our way. So the first thing I'm going to do is, now that I know that this is going to be a CTE, I'm going to wrap this in a CTE. So I have my query here. The first thing I'm going to do is I'm going to highlight the whole thing and I'm going to hit tab. Okay. And now he's ready to be wrapped. So we're going to put with base as open parentheses, or the left parentheses, scroll all the way to the bottom, close parentheses. And the reason why I want to do that is because I can do this. Shazam. Okay, so now I know this is part 1 and he's the base. Okay, part 2. I'm going to put that right down here. That way I can kind of keep track of everything. And I'm going to close the second window now because it's getting a little too much for my eyeballs. Okay. So part 2. 1, wrap your query from part 1 in a CTE called base. Okay, we did that. Great. 2, use function STDistance using geopoint_end, geopoint_start to find the distance in meters. Great. Use part 2 to convert the output into miles. Divide meters by 1609. Filter any trips where the total trip time was greater than 12 hours. And then wrap this query in a CTE called dist. Okay. So we already did part 1. Good. Let's work on part 2. So the first thing we could do is if we did select star from base, what this is going to do, it's going to return the same query. And it's going to have the same amount of rows. But let's go ahead and do it just to verify. Okay, good. Everything looks great. So now we're going to use the function stdist, okay? So what I'm going to do now is, instead of selecting all, I'm just going to do bike ID, month, and then I'm going to do start geo, end geo, now stdistance. And the distance, you put the end first and then the start second. And then convert the output into miles. So this is going to be as dist meters. We want to convert this into miles. So we divide by 1609. How do I know that? I Googled it because I live in America and I don't know the metric system, unfortunately. It's a big bummer on my part. Okay, so safe divide. What are we dividing? We're dividing this crazy thing. He's going right in here, comma, 1609 as dist miles. Okay. And then filter any trips where the total trip time is greater than 12 hours. Why are we doing that? Well, if you had a trip greater than 12 hours, I'm going to assume that that's wrong. You weren't biking for 12 hours. And maybe if you did, but you're probably an outlier, so it's okay. Oh, and we need trip time. What did we call it? Trip hours? Trip hours. Okay. Where trip hours is less than 12. Okay, so let's run this. Okay. So I have the bike ID, the month, the trip in hours, the start, the end, the distance in meters, the distance in miles. Okay, and it looks good. And you can see that I cut off quite a few rows. This used to have an 8 in front of it, and now it has a 4. So there are actually a lot of trips that are greater than 12 hours. So what that would indicate to me is either there's a lot of bad data in here, or maybe people are taking these bikes for like work, and they're traveling to work, and they're staying there, and they're going to the bar, and then they're hanging out at a friend's house, and their bike's there overnight, or something crazy. Okay. Part 5. Wrap this query in a CTE called dist. Okay. So now I'm going to call this dist. So comma, dist as, open parentheses, and I'm going to tab this chunk right here in, shoop, close parentheses. Okay, and now I'm ready for part 3. Part 3. Query dist and find the following for each month. Number of riders, average trip distance, average distance. Okay? So this is what dist is going to look like if I open him up. He's going to have the ID, the month, the hours, and then the distance. So this final part, what I want to do, I want to select, let's see, number of riders for each month. Okay, so we're going to start with month. Then I want to count bike ID as total riders. The average duration is just going to be the average of trip hours. Average trip hours as average ride time or trip duration. Okay, and then the average distance. Average, and let's do it in miles and meters. That way, if you're anywhere, you'll understand what it says. Average, what did I call it? Distance miles. Okay, distance miles as average miles. Average distance meters as average meters. From where? From distance. Okay? But since I have all these aggregate functions, I have to have a group by month. And then let's also do order by month, because I don't want to see the months out of order. That's going to drive me nuts. Okay, so now we have this, we have the green check mark, Control Enter. Okay, here we go. So now by month for 2014, we have the total riders, the average trip duration, and how long it took in miles versus meters. And if we were looking at this for analysis, we would probably see, oh, is there any kind of seasonality by month in terms of trip duration, miles or meters? I don't see anything. It looks pretty similar for the most part. That all looks pretty similar. What doesn't look similar are the total number of riders. So you have your riders, and they might be a little seasonal, but what they do each month is pretty similar, what it looks like. Okay, great. Let's jump back to that PowerPoint and wrap up this lesson. Okay, so in this lesson, we learned new functions, stGeoGPoint and stDistance, and we learned how to link multiple CTEs. In our next lesson, like we did in the previous module, we'll replicate the same example using a subquery. See you then. I hope you found this video helpful. If you did, I would be so appreciative if you could like the video and subscribe to help me create more content for you. Thank you.